In this video, we are going to discuss about a problem on Routh Howard's criteria. So the question is g of s is equal to k divided by s plus 2 into s cube plus 10 s square plus 49 s plus 100. So they are asked to find the range of k so that the system is stable using the Routh's array, and asked to determine the value of k which causes the sustained oscillation in the system, and then determine the frequency of the sustained oscillation. See here, g of s value is a open loop transfer function, and h of s value I have to take it as 1. So what is my transfer function is t of s is equal to g of s divide by 1 plus g of s into h of s. So in order to find the characteristic equation, I have to take the denominator value is equal to 0. So 1 plus g of s into h of s is equal to 0. Now h of s value is 1. So I'm going to substitute the g of s value here. So 1 plus k divided by s plus 2 into s cube plus 10 s square plus 49 s plus 100 is equal to 0. So if I denominator function, if I multiply the denominator function on the both side, I will get s power 4 plus 10 s cube plus 49 s square plus 100 s plus 2 s cube plus 10 20 s square plus 98 s plus 200 plus k is equal to 0. So you can see I'm going to take the common term s power 4, and 10 s cube plus 2 s cube is 12 s cube plus 69 s square plus 198 s plus 200 plus k is equal to 0. So now I'm going to take the Routh's array. So first you have to take s power 4. So what is s power 4 value? 1. Coefficient value is 1. Then s square value is 69. Then constant term 200 plus k, that is equal to 0. So here you should not take 200 plus k which is greater than or equal to 0. Okay, that will be a wrong value. Next I'm going to take s cube value. So what is s cube means? It is 12, coefficient is 12, then s is 198. Then in order to find the value of s square, you have to multiply 12 with 69 minus 198 into 1 divided by 12. In similar way, you have to multiply 12 with 200 plus k minus 0 divided by 12. So on solving, you will get the value as 52.5, and this one is 200 plus k. Now again, you have to multiply the 52.5 with 198 minus 12 into 200 plus k divided by 52.5. So you will get the answer as 7995 minus 12k divided by 52.5, and this value is 0. Next, in order to find the s power 0 value, so you have to multiply 7995 minus 12k divided by 52.5 into 200 plus k minus 0 divided by this value. Okay, so on solving you will get 200 plus k. So now you have to take 200 plus k is greater than 0. So if I move the 200 to the right hand side, I will get k is greater than or equal to greater than minus 200. Now I'm going to take 7995. 995 minus 12k divided by 52.5 is greater than 0. So now if I solve, I will get 7995 is greater than 12k. So 7995 divided by 12, you will get the answer as 6.5. Okay, so the range of the k must be minus 200 between minus 200 and 666.25. Okay, so the second question is determine the value of k which causes a sustained oscillation in the system, and then determine the frequency of the sustained oscillation. So now you are going to substitute the k value is equal to 6606.25. Why? Because to have the sustained oscillation, um, all the element in the row must be equal to 0. Okay. So how to make? So I'm going to make this S term. So 0. So I have to substitute the k value is equal to 666.25. So if I substitute k is equal to 66.25 in the 7995 minus 12k divided by 52.5, it becomes 0. Okay. So all the element in the fourth row is 0. Right. So in order to find the frequency, I'm going to take the S squared term. So the S squared term is A square, just its value 52.5 S square plus 200 plus K, that must be equal to 0, and the K values I have already told you it is 666.25, right? So you substitute that value. So you will get 52.5 S square plus 866.5. So from this, I can write S square is equal to minus 866.5 divided by 52.5, right? So this must be equal to S is equal to plus or minus J 4.062. So S value is equal to, if I substitute S is equal to j omega, I will get the j get cancelled, so the omega value I will get. So that is nothing but frequency of the sustained oscillation. So that must be equal to 4.062 radian per second. Since frequency is not in the value of negative, I can take this one as since it is a angular frequency, right? So it must be in as a omega. It has to be represented as omega, and the formula unit for the omega is radian per second. So I hope this video is useful for you. So in order to see my other video, you check the link in the description box. So if you have any doubt also, you can ask the question in the comment section also. So thank you very much.